In this video, we're going to talk about function notation on a graph. So by the end of this video, we should be able to read and use function notation with a graph. So let's talk a little bit about function notation, that f of x again, and how it relates to how we are used to seeing it and how we're going to see it going forward. So we're used to seeing points on a graph or ordered pairs looking like this, written x comma y. So for example, we might see an ordered pair as 1 comma 3. Now what we're going to see with function notation means the same thing, we just write it a little bit differently. And so an ordered pair now looks like x comma f of x. Right? Both are still stating an input and an output. When I put x in, I get y out. Or when I put x in, I get f of x out. And the way we write this with function notation, so as an ordered pair, it's still going to be 1, 3. However, we're also seeing now f of x equals y. So how I would write that is f of 1 equals 3. The input is 1, the output is 3. So let's see one more example of that. If you have an ordered pair, let's say 1 comma 4, and I want to write it in function notation, I would write that f of 1 equals 4. I can also go the other way and say that if we have the point f of negative 3 equals 11, I could write that as an ordered pair, negative 3 comma 11. Okay, so in general, we have x comma y in function notation is f of x equals y. Okay, so let's take a look at that on the actual graph. So this graph, we're going to name k of x. Okay, so let's label this. The graph's name is k of x. My x-axis is the horizontal axis. The y-axis, or the output axis, so k of x in this case, is the vertical axis. So let's do a couple things. We're going to label k of 1 equals 3, and then find a couple other points here. Okay, so I've written a couple more questions. So let's do all of these things. So let's start off with number 1, label k of 1 equals 3. So that is the ordered pair 1 comma 3. So that means my x is 1, and that point is right on the line, so that is 1 comma 3. There we go. Done with number 1. Let's take a look at number 2. So we're going to find k of negative 1. So that's telling us that x is negative 1. So on my x-axis, I'm going to go find negative 1, which I see right here. But I have to find the point on the graph where x is negative 1. It just so happens that y is also negative 1. So my answer here is negative 1. All right, number 3. Okay, same idea, different numbers. So k of 1.5, what's the output? So my input x is 1.5. So on my x-axis, I go to 1.5. I go up to where my function is, and I see that the output here is 4. So k of 1.5 is 4. When the input is 1.5, the output is 4. All right, and now we're going to go the other way. So this time we're given the output, meaning we're given the y value, and we need to find x. So on this one, the output is 0. So I'm going to go to my k of x axis here. The output is 0. I need to go find my graph. There we go. All right, and turns out that is also the x-intercept. All right, and it looks like that is negative 0.5. So here, x is negative 0.5. All right, and last one for this graph, k of negative 2. So the output on the y-axis is negative 2. I go there, so here's negative 2 on the y-axis. I got to go find my graph. There it is. And I have to read the input. So that input is negative 1.5. And there we go. Let's look at two last examples here on this absolute value graph. So the first one is f of 0. So when the input is 0, so that means on the x-axis, I'm looking for 0. So here's 0 on the x-axis. I go find my graph, and the output is 5, meaning the value on that y-axis, right, that is 5 right there. Okay, so done with that. That makes sense that we only have 1, because remember, to be a function, for one input, you can only have one output. However, when I am asked to find x, when the output is 3, this does have two answers. So let's go find the output of negative 3. So on the y-axis, that's going to be right there. I have to go find where that is on my graph. And I notice I have graph or function both to the left and to the right. So here and here. So I have two solutions. X can be negative 6 and 2. Meaning when the input is negative 6, I will always get negative 3 as the output. When the input is 2, I will always get negative 3 as the output.